Find the height. For investigation number 4, we chose a lamppost as our fourth object. We decided to use Rakshan's measurements as his measurements were the most accurate compared to everyone else's. His shadow measurements were 142 centimeters and his height was 158.2 centimeters. The shadow length for the lamppost is 280 centimeters. What we were trying to solve is the lamppost's height. Similar triangles are triangles that have 2 or more congruent angles. When a triangle has 2 or more congruent angles, it gives them proportional sides, which can be used to indirectly measure something. In our experiment, our similar triangles were the lamppost and its shadow, and us and our shadows. The shadow on the lamppost created a 90-degree angle, and Rakshan and his shadow created a 90-degree angle. With this, we had one similar angle, and the second one came from the sun. The angle created by the sun and the end of the shadows determined the end angle.
Now that we have 2 triangles with at least 2 equal angles, we knew that they were proportional. We can prove that with the math. When we have 2 equal angles, then the third one must also be equal. And if we have 2 triangles with all the same angles, those triangles must also have proportional sides. Once we know that the triangles have proportional sides, we can do the math.
So, to solve for x, which is the height of the lamppost, all we need to do is make 2 fractions. The first one is 117 over 294, which is the length of Rakshan's shadow, and the corresponding shadow length of the lamppost. And that is to equal the other fractions of 158 centimeters, which is Rakshan's height, over x. So to create our equation, we have to cross multiply. 294 times 158 is 46,452. And 117 times x equals 117x. To find the height of the lamppost, we have to divide by 117 to make x alone on both sides. And that turns out to be 397.02 centimeters. So after doing the math, we can approximate the height of a lamppost is 397.02 centimeters.
For our indirect measurement and or estimated measurement, we use the shadow lengths and the actual heights since they are proportional. We then set up a simple equation using the variable x to find an approximate height for the lamppost, which is around 400 centimeters. For a direct result, we used a meter stick and estimated how many times it could have been stacked on top of itself, and finally, we got a measurement of 432 centimeters.
Possible causes for wrong measurements or errors. One of the biggest things that could have caused an error in our calculations is the position of the sun and the rays it radiates. Depending on what time it is, the sun transitions in different positions and that can affect the shadow, which is a vital number in our calculations. Another possible error was human error, where we could have slouched or moved a little bit, which would alter our own height, and that was a fundamental measurement as well.
Thank you for watching.